Antarctic or in the freezer will not grow 20. Now 20 degrees, go 10 and 20, 50, 68, so add 18, add 18. So 20 degrees would be 68 Fahrenheit. These guys don't grow at that temperature. Really not above 15. Now there's a subset called cycrotrophs. The cycrotrophs have a much broader range from 0 to 25. So we just saw 20 degrees is 68 Fahrenheit. We're adding 5 centigrade, so at 9 Fahrenheit, that would be 77. 77 degrees Fahrenheit. Now these guys live in the refrigerator. Now you might wonder what kind of refrigerators go to 77 degrees. Well, clearly not a very good one. But the point of this really is not that the refrigerator is 77, but you're always opening and closing a refrigerator. That's where the problem is. Because the cycrophiles, even having the momentary exposure to warm air coming in, that's probably enough to kill them. The cycrotrophs can't put up with it. So, anyhow, they both are cold weather bacteria. This is why food can spoil in the refrigerator. There are bacteria that will live at those temperatures. It's a lot slower, but they will still do it. Mesophiles. Well, meso means middle. So these guys like little warmer temperatures, from 25 to 40. So 10, 20, 30, 40. So 50, 68, 86, 18 more now, 104. So again, for every 10 degrees here, add 18 over here. Starting with 0 and 32. So we have 4 10s to go to 40. We need 4 18s. So 50, 68, 86, 104. So these guys are basically growing between 77 degrees and 140. What's of more interest here is they can live inside us. What's our body temperature in centigrade?
96, 97, 26.
37. So those are mesophiles. Any of the bacteria we have are mesophiles, including the pathogenic bacteria. Any of the bacteria that make us sick automatically are mesophiles because they have to be able to tolerate 37 degrees temperature. Thermophiles. Still moving up. So these guys like between 50 and 60 degrees. So we saw 40 is 104. Add 18 again. 50 would be 122. 60 would be 140. These don't have to be precise. So basically here between 120 to 140. Hot springs. If you don't find temperatures like this very often. By the way, a lot of people like to go into hot tubs and stuff, and they do feel good. And there is always a danger of bacterial infection and so on. Many people think hot tubs are too hot. Bacteria won't grow in those temperatures. Well, yes, they do. And the mesophiles will grow because 104 is typical for a hot tub. Now, there's lots of bacteria that can grow at those temperatures. So anyhow, I guess I'm not saying don't do a hot tub. Don't drink the water. These guys won't go below 45 degrees. So that would be, again, 40 is 104, 50 is 122. So 9 more or 9 less would be 113. I'm not going to be asking you to convert. This is just for your information, but that won't be on any quiz or midterm. Compost piles get very warm because these guys are working away. The final category, extreme thermophiles. So these guys like it really hot, 80 to 90 degrees. Well, frankly, that's too many 10s. So let's go backwards. Let's go up to 100 and work our way backwards. To 100 corresponds to 212. Take away 10 degrees, that would be 90. Take away 18 from the 212, that would be 194. Take away 10 more, so that'll be down to 176. So ballpark figure between 175 and 195. You find these near volcanoes. If you're swimming in water like that, you deserve what's going to happen to you. You shouldn't be swimming near volcanoes. So. But anyway, you can see, man, I mean, the range is literally from freezing to boiling. Now, minimum, I'm going to put all three up here. Optimum growth temperature is the temperature where the organism likes best to grow. You know, if any of us were asked, what's our best temperature? I think most people would say between 70 and 75 degrees, probably. Above that, you're feeling a little bit warm, below, maybe a little, cool. Still okay, but probably best, 70 to 75. But most organisms have some best temperature. It does not mean they cannot live at other temperatures. So minimum would be the lowest temperature where the organism can still grow. And obviously maximum would be the highest. Now, of course, humans are a little bit weird in that because we have heated houses in the winter, air conditioning in the summer, but some people do. So clearly those temperature ranges probably apply to us. But in terms of biologically, we can make some kind of argument. But minimum, optimum, maximum, kind of a bell-shaped curve type thing. pH, another factor. Most bacteria will grow at neutral pH. So neutral pH is 7, you know that. But there will be a range of 6.5 to 7.5. Technically, we like neutral also. Most organisms do. But our pH actually is around 6.8. It's a teeny bit on the acidic side. And the reason is we eat proteins, which have amino acids, and of course lipids that have fatty acids. So that's why we're a little bit on the acidic side. But essentially neutrality is what most organisms work at. But there's always variation. Most bacteria won't go below 4. 4 is fairly acidic, but not terribly so. For example, orange juice, citric acid, is 4.5. So 4 is acid, but it's not bad acid. But there are acidophiles that can grow at a pH of 1. Now the acid in your stomach is a pH of 2. So this is highly acidic. Molds and yeast can actually grow at a lower temperature than bacteria, down to 5. Now you might wonder, well, I'm kind of contradicting myself. Because here I'm saying bacteria don't go below 4, these guys don't go below 5, but I'm saying they go below bacteria. Well, the bacteria show more variation, but as a group, the bacteria tend to be above pH of 5. So as a group, the mold and yeast tend to be lower than the bacteria. But taking individual bacteria, you can get more variation. Some will go down to 1. So actually it works. It works despite how it looks. Basophiles, well, you can guess. They lack basic pH. So above 7. Osmotic pressure, I don't think I've used that term before. Let's use it now. Going back to osmosis and hypertonic and hypotonic solutions. So remember, in all mammals, all of our cells are 0.9% salt. That is a number you really should know, because you're going to run into it forever. So 0.9%, although frankly, to be really precise, it's 0.85%. I'm just rounding it to 0.9. So all mammals have that because you all have the same ancestor. So isotonic solution is when you have the same concentration inside and outside of the cell. Again, in this case, 0.9. Hypotonic solution is when the concentration outside the cell is below 0.9, and hypertonic is when it's above 0.9. So in hypotonic solution, water goes into the cell, and the cell at least dilates, if not ruptures. It probably ruptures, but no guarantee. Hypertonic solution, which is crenation, let me rephrase, I'm sorry. I want to rephrase. In hypertonic solution, water leaves the cell shrinks. That's crenation. So the crenation is the shrinkage of the cell in hypertonic solution because water goes out. Now in bacteria, it's called plasmolysis. The same thing happens, but now the cell is shrinking. The cell wall does not shrink. It kills the cell. So the bacterial cell will pull, the membrane will pull away from the cell wall and kills the bacteria. That's why for centuries and centuries, before there was refrigeration, the only way of preserving food was salting it. So salted meat, salted fish, and so on, that's how meat was preserved. They didn't know how it worked, they just knew it did work. But that would be crenation. But osmotic pressure is the ability to resist the rupturing. So in hypotonic solution, how easy is it for the cells to resist rupturing? We did talk about that with peptidoglycans. The gram-positive cells are quite resistant. The gram-negative cells less resistant to rupturing, and our cells barely resistant. But there are always variations, as you've heard me say 100 million times. Extreme halophiles. That halo means salt. The halo means salt. So there are bacteria that like high salt concentrations. There are bacteria that like high salt, up to 30% salt. Now that actually is extremely high. In fact, you hardly ever find it. As far as I know, there are only 2 places on Earth that have it. I told you a long time ago, the salt concentration of the ocean is 3.5% salt. That's changing now with global warming, but traditionally at least 3.5% salt. So where do you get something that's 9 or 10 times more than that? The only 2 places I know of would be the Dead Sea in Israel and Great Salt Lake in Utah. I've never been to the Great Salt Lake. I have been to the Dead Sea. And the reason, it's got 10% salt, so 3 times what the ocean is. And the reason it's got that is the Jordan River comes down into the Dead Sea. The Dead Sea is the lowest spot on Earth. It's 1,100 feet below sea level. And by some miracle of nature, the amount of water evaporating every day from the Dead Sea exactly matches how much water is coming in from the Jordan River. So the water level never changes. But what is changing is the salt balance. Because even though rivers are fresh water and lakes and stuff, but they actually do have a little bit of salt in them. It's just that the salt level is so low, you cannot taste it. So anyhow, over thousands of years, maybe millions, I don't know, but certainly over thousands of years, the salt concentration of the Dead Sea keeps going up. And the same thing for Salt Lake. It keeps going up because there's always some salt being brought in. So nowadays, it's over 10% salt. Actually, if you go swimming in it, you cannot sink. You cannot sink. So all the stupid tourists went on out there, we all had the same dumb idea, you know. We all were there, you can't sink, so you just float there on your back. Down any lake, you're always going to have these little potholes, or I can't think of the term, but little holes, little puddles around the lake. So water will splash in, evaporate, more water splashes in, evaporates. That's where you get 30% salt. And there are bacteria that live there. There are bacteria that live in the Dead Sea. So those are extreme halophiles also. So it's hard to find something like that, but it does exist. There are bacteria that will live there. Facultative halophiles. That word facultative you haven't seen before, but you will be seeing it again. Excuse me. What it means is that the organism can go in two directions. In this case, they can grow in fairly low salt concentration, 2%. That's higher than us, but still lower than the ocean. Or it can go up to 15%. That's the facultative. It can do fairly low, it can do fairly high. So they're facultative halophiles. And then most bacteria will actually prefer around 1%. The ones that live in us prefer 0.9. So you get the idea. Some, we talked about temperature, we've talked about salt, we talked about pH, and some others on Thursday. So we're going to finish this off on Thursday, and then also do the very last chapter, which is control. We'll finish easily on Thursday, and then talk about the midterm, et cetera, et cetera. Any last questions for right now? Okay, let's stop.